Computer programming requires an understanding of Boolean logic. Now, Boolean logic is simply the ability to test conditions and determine whether they are true or false. For instance, if we're running a payroll program, we might want to look at hours. Are the hours greater than 40? That would determine whether or not we would pay overtime. If the hours are greater than 40, perhaps we would compute an overtime premium. If not, we don't. Hours greater than 40 is what we would call a simple condition. And again, it can either be true or false. In reality, we do not pay overtime to salaried employees. So if we're looking at hours for an employee that may be salaried or hourly, we have to have a compound condition to test. Hours greater than 40 and hourly employee status. Let's get started. A condition is a statement that is either true or false. Compound conditions consist of two or more statements joined together by a logical operator. Now, a logical operator might be an and, an or an exclusive or, E-O-R, exclusive or. This truth table illustrates how a compound condition joined by and works. In the bottom left-hand corner, we have our compound condition, A and B. Now, the rules of and specify that both sides must be true in order for the compound condition to be true. So, we have two conditions listed, A and B. A in the top row, B in the middle row. There are four different combinations of truth here. A may be true at the same time that B is true. Or A may be true and B false. Or A false and B true, or perhaps they're both false. But the compound condition is true if and only if both A and B are true. Then we have a compound condition joined with an or, A or B. The same table, the only thing that we've done is change the compound condition. Now, the rules on the or are that if either side, A or B in this case, is true, then the entire thing is true. So it's true when both A and B are true. It's true when only A is true. And it's true when only B is true. In fact, it is only false when both A and B are false. Here we have the exclusive or, E-O-R. A, exclusive or B. The rules on the exclusive or are that the compound condition is true only when one and only one of the two sides, A or B, is true. If both are false, it's false. If both are true, it's false. So only when one and only one of our two conditions, A and B, are true, is our A exclusive or B true. And then we have not. Now, not doesn't really join conditions. But what it does is reverse a truth value. It's like putting a minus sign in front of a number. Rather than reversing the sign of a number, though, not reverses the truth of a condition. So, think back to A and B. A and B as a compound condition was only true when both A and B were true. But if we throw parentheses around A and B and precede it with a not, we're saying we want the reverse of this condition. So we would reverse the truth value, and the only time this expression becomes false is when both A and B are true. Nots are kind of tricky, so avoid them whenever possible. Here's another example, not A or B. Now remember, the rules on an A or B are that our compound condition was true whenever either side was true. Okay? But if we negate the entire compound condition, we get just the reverse. It's true only when both A and B are false. See? Those knots will trick you up. Now, there is an order of operations here, just like algebra. In fact, these are an extension of the algebraic order of operations. So after we would do our addition and subtraction, then we look for logical operators. And the first thing that we would do are any knots from left to right, then the ands, and then the or and exclusive ors. Now that's a lot of material, so if you didn't grasp it all, you might want to take another look through or do a Google and see what you can find out.